Chapter 6, Section 1. In this section, we're going to learn how to form a composite function and how to find the domain of a composite function. So let's look at the first topic, form a composite function. We use this example to illustrating what is a composite function. Suppose that an oil tanker is leaking oil and you want to determine the area of the circular oil patch around the ship, okay, like the graph. So this is oil tanker and then there's a leaking, okay, there's a hole, so the oil is leaking into the seawater, all right? And the oil is leaking from the tanker in such a way that the radius of the circular patch of oil around the ship is increasing at a rate of 3 feet per minute. So that means we can model the radiance, okay, as a function of time t, okay, which is radiance is equals 3 times t. So for example, if after 20 minutes and then the radiance of the oil patch should equal 3 times 20, which is 60 feet, right? And then we want to find out the area of this circular oil patch, right? So the radiance is increasing. So that's why the oil patch actually is getting larger and larger, right? So the area of the circular patch can be modeled as, right, area can be modeled as a function of the radiance r, which is equals pi times r squared, right? That's how to find the area of a circle. So if the r radians equals 60, and then pi r squared will equal 3600 pi. Okay, that's just for illustration purpose. Okay, so we use this example just kind of illustrating this composite function. Okay, this function actually involves two functions here. All right, first function is the radiance is a function of t. And the second function is the area function is a function of the radiance, okay, which is pi r squared. So we can substitute r into the second function, right, which is equals pi times 3t and then parentheses raised to the second power. So 3 need to be squared, t need to be squared. So after we simplify, we got a 9 pi t squared. Okay, this is what a composite function means. It involved two functions, and then actually this function's input, okay, r actually is the other function's output. Okay, so we, combine the two functions into one. That's why we call it composite function. All right, so now let's look at the definition. What is a composite function? Given two functions, g and f, okay, just in general, we denote one of function as f, the other function as g. The composite function denoted by f composed with g. Okay, so we use this open circle represent composed. Okay, f composed with g. So be careful here. This is different than function f times g. If it's a closed circle, okay, that's represent the multiply. This is two function multiply. But open circle, that's represent the two function composed with, okay, which is left-hand side of the open circle. This is called a outer function. And the right-hand side of the open circle is called a inner function. Okay, outer function and an inner function. So f composed with g of x, that's equivalent to outer function is f of x, and then inner function is a g of x. Okay, so g of x, that is the input, of function f of x, okay? And then in the function g of x, which is inner function, and actually x is the input. Okay, so we go through two functions. So the input x goes through the inner function g of x first, and then goes through outer function f of x. All right, so actually there is a figure it can illustrating the purpose. Okay, the input independent variable x first goes through function g of x. Okay, and then output of the function g of x is g of x. And then the output of g of x is served as the input for the outer function f of x. And then finally produce the output, which is the composite function's output. Okay, so it goes through inner function and then outer function. It goes through two different functions. That's why it's called a composite function. Okay, so I skipped the one slide. The previous slides is talk about the same thing, but in the perspective of domain and range. Okay, so this is the domain of inner function g of x. Okay, and a mapping, and then we got a range of g of x, right? And then the range, which is output of g of x, actually serve as input of another function f of x, which is outer function. So that means the range of inner function must be part of the domain of outer function, and then finally get into the range of composite function f composed with g. All right, so it goes through two functions, inner function and an outer function, and then finally produce the output.